All right, everybody, we're going to continue on with Chapter 7, where we describe Linux file structures, Macintosh file structures, and use Linux forensics tools. There are many Linux forensics tools out on the market today. Some pay, a lot are open source, meaning they are free to you. We'll go over one specific one in our Chapter 7 assignment after our Chapter 7 PowerPoint slides, where we'll then have Chapter 7 review questions, and we'll be unlocking Chapter 7 quiz with a passing grade of 70 or more. Our Chapter 7 hands-on assignment today focuses on autopsy. Developed by SleuthKit, you can either get it from our on-site FTP or from the autopsy download link, where they go over 4.0, 4.4.0, or 4.3.0 or 4.5.0. That's their newest one now. It'll keep growing in versions as it goes along. The lab that we have runs 4.3.0. So if you want to follow along with the instructions we have, 4.3.0 will be exactly as you see it. But if you find that 4.4 or 4.5 version, be a little different. So if you have a Android phone, this lab will work very well for you. If you have an iPhone, you won't be able to do live imaging or live forensic acquisition of it. You'll only be able to monkey around with the backup of it so long as you didn't password protect your backup. If you did, you'll probably enter the password. That way you don't have to worry about removing the password lock on it, just to make it easy. If you don't have an Android and you don't have an iPhone, you've got some third-party Windows or Google phone, just play around in Autopsy. It's not for this assignment. I'm just looking for your input on it, your findings, so to speak. What good information did you find? Don't share any information you're not comfortable with sharing. I'm not interested in seeing that. I'm more interested in your personal opinion about the software itself. Did you find something you didn't expect to see on your phone? If you did, hopefully it opens your mind and explains the process that forensics has with how it operates on smartphones. Since most of us have either a Android-based Linux sort of style phone, or maybe even a Linux-styled Mac iOS phone, that would be another option. It's more of an exploring kind of thing. It can load on any Windows operating system. The SleuthKit, I don't believe they've implemented any other, like Mac OS or any other program. It's all MSI for Windows. So if you don't have a Windows machine, try and get to one, load that, check out Autopsy. That's all I'm asking, is you check it out, play around with it, explore it, and just basically, what information did you find? Report your findings. What did you feel about it? How did you feel about the software itself? So with that, we'll move into our Chapter 7 lecture. It's very short, so we'll move into that now. Let me flip this around. All right, where we describe Linux and Macintosh file systems, the file structures, Macintosh structures, and Linux forensics tools. Unix flavors through Irix, Santa Cruz, UnixWare, Sun Solaris, IBM, and HP UX is based, or Linux is based off Unix, Ubuntu, Debian, Red Hat, SUSE, Slackware, CentOS. There are tons of Linux distributions. All Linux-like OSs will have a kernel. So does operating systems with Windows. So some of the file structures to look at. System files are going to be like the exports fstab, lastlog, wtemp, utemp, dmessage, syslog, shadow group, and password. So we've got top-level domains, user, etc, home, root, dev, and var have their various internal configurations and settings. Now, Unix and Linux commands are case sensitive, as is their file structure as well. The wrong capitalizations means that your commands are going to get rejected or interpreted incorrectly. Some Linux commands for activities, 289 to 291, echo command adds notes or headings to those logs. The early file system started at EX2 or EXT2, then EXT3 and EXT4. As we grow in EXTs, you'll notice that the support for partitions get larger. Everything is a file. Files are objects with properties and methods. Unix consists of 4 components. The boot block is an allocation of 512 bytes and contains the bootstrap code. Linux has only one boot block located on the main disk. Superblock is the disk geometry space location of the first inode, manages the file system. Inode blocks are the first data after the superblock assigned to every file allocation unit, and data blocks are where directories and files are stored. This location is linked directly to inodes. They contain directory and file metadata, which is also stored in the data blocks. The assigned inode contains the following: the mode, type, and file, the number of links in file directory, the UID and GID of the file's directory owner, number of bytes in the file directory, files or directories last access time and last modified time, which also have the inode's last file status change time, the block address file data, indirect, double indirect, triple indirect block addresses for the file data, usage statuses for the inode, the number of actual blocks assigned to a file, file generation number and version number, and the continuation of the inode's link. The first inode has 13 pointers. 1 through 10 are direct pointers to direct storage. Number 11 is the indirect pointer, which links to 128 points inode. Each pointer links to 128 blocks. 12 is the double indirect, and 13 is the triple indirect. And we can see how the inodes structure out from there. The bad block inode keeps track of the bad disk sectors. When it finds these bad blocks, they use the following commands to find them. Bad blocks, you have to be root to use that command. MKE2FS and E2FSK are safeguards to prevent them from overriding information. The hard link points to accessing the same file by different file names. The ln command is used to create the hard link. So in this listing, when you run a list or directory for a specific directory, your ls-a shows all, and we can see that the dot, dot, and the dot notation are set as well. Dot being the current directory, dot, dot indicating the parent directory. So if you change the directory up a level, you'd change it using the 2 dots. The symbolic links are pointers to other files that haven't or aren't including the link. They're known as soft links or sim links. They are able to point to items on other drives or other parts of the network. And inode are contained within, they have their own inode. They depend on the existence of the destination they are pointing to. So that's what we call broken links. And here we can see in the very beginning, we up a directory by change directory cd ... make the directory test sin or sim sym. We changed the test sim. Now we're in temp test sim, where we touch test 1, touch test 2. We go back up a directory and we list out the my sim with the listing for my sim we see as test 1 and test 2. If we look back at that, we can then see all the read-write attributes for students, the user student who's logged in currently, the listing for read-write access, read-write execute, read-write execute, read-write execute. Accessed August 12th, 2028, or August 2012, August 28th at 12:18. The my sim with the symbolic link temp test sim. So now we're going to look at Macintosh file structures. 10.9 codename Maverick, 10.10 is Yosemite, and we're all the way up to, I can't remember the most current operating system, but it's changed several times since then. It'll continue to change. OS X is built on Darwin, which is the BSD Berkeley Software Distribution Unix application layer. The Macintosh moved to the Intel processor with OS X and became Unix-based. The OS X, the hierarchical file system HFS, was prior to OS X. Now that we're in OS X, introduced in OS 8.1, became HFS Plus, the extended file format system. Supports smaller file sizes on larger volumes, resulting in more efficient disk usage. In Mac, they use two parts, the data fork and the resource fork, which stores metadata and application information. The data fork contains data the user creates, such as text or spreadsheets. Applications also read and write to this data fork. A volume and is the storage medium used to store files, can be all or part of the storage media for hard disks. So we see how the simple Mac file creates both the data fork and the resource fork in each block. Volumes have allocation and logical blocks. Logical blocks can't be larger than 512 bytes, and the allocation blocks are a set of consecutive logical blocks. Two end-of-file descriptors is a logical end-of-file and the physical, with the logical being the actual size and the physical being the number of allocation blocks for that file. And we can see how we see the file allocated A, B, and C have the logical blocks and the allocated blocks. Again, we see that again. Where file B spans allocated block 1 with logical block 4 and logical block 5 with the end of files in position. So clumps are a continuous allocation blocks group. They reduce fragmentation. The older Macintoshes used two logical blocks with 0 and 1 as boot blocks. Master directory block and volume informational block stores all information about a block, and the volume control block stores information about the master directory block when the operating system mounts. It extends the overflow file and stores any information not in the master block in the volume block. Catalog is a listing of all files and directories in the volumes and maintains relationships between files and directories. The B star tree is an earlier Mac system where the actual file door data is stored on leaf nodes. B tree also uses header, index, and map nodes. There's some differences between Linux and Mac file systems. Linux has the host username and root directories. Mac have users, username, and private var root. The home directory exists in Mac operating system, but is typically empty. Mac users have limited access to other users' accounts, and the guest account is disabled by default. You can turn it on. Forensics procedures for Mac OS means you have to know where the file system components are located and how both file systems are stored. Application settings are in three formats: plain text, plist files, and SQLite database files. The plist files are preference files for installed applications on the system. The file vault is used to encrypt and decrypt users' directory. Keychains are files used to manage passwords for applications, websites, and other access. The Mac application keychain access enables you to restore passwords, view, modify, and look at those as well. Deleted files are found in the trash file, and if it's deleted at the command line, it doesn't show up in the trash. So similar to command line for Windows and Windows operating systems. Macintosh acquisition methods: you make an image of the drive. Static acquisition of the suspect drive is preferable to live acquisition. Removing the drive from the Macintosh mini CPU is very difficult because it's a very small. It's the Mac Mini. This is where it comes into what they'll call Apple factory training. You don't have to be, but when you have Apple factory training, you learn how to take apart the Mac Mini, MacBook Pros, Mac Airs, iPads. All of that stuff is part of Apple factory training. And it is very specific and it is very useful skill to have. A Macintosh capable or compatible forensics boot CD is what you'd use to make your image of your drive. Black Bag Technology sells acquisition products for OS 9, X, and more. Macquisition is a forensic CD used to make images, and after making the acquisition, then you'll examine the image of the file system. The tool you want depends on your file format. Black Bag Technologies, Macintosh Forensic Software, and Sub-Rosa Soft Mac Forensics Lab can disable and enable disk arbitration. Being able to turn on and off the mount function allows you to connect the suspect drive without a write blocking device. Some more tools. We've got Black Bag forensic software, Sub-Rosa Soft Mac Forensics, Guidance In-Case, X-Ways Forensics, Access Data FTK. Commercial computer forensics tools Analyze X2, 3, and 4, Riser FS, and Riser 4. Freeware such as SleuthKit and web browser interface offer Autopsy and Forensics Browser. Foremost is a freeware carving tool that can read many imaging files in the configuration file foremost.conf. So the same way that we do zip files in Windows, or we do compression for Windows, Mac does it a little different. So does Linux. All right, they use tarballs, which is a file containing one or more files and their contents. It's compressed, but it's a little different, and that's a data file that contains directories and their contents. So SleuthKit, installing an Autopsy, I run you through that here in the lab. The Autopsy browser, you need to have root privileges. So in your evidence locker, you'll load the Autopsy, which is held at Home Student Documents Evidence Locker. It then pops localhost at port 999. So localhost is the IP address of the software you're choosing to use. So in this particular one, in Ubuntu, they ran Autopsy. So Autopsy Forensic Browser 2.24, which is pretty old. This is how you start your casework. It's a web browser, so it installs its own LAMP step. So the instructions run just through 7.14 to 7.15, with 7.14 being the create new case dialog box, where you are the investigator and the description of the case and the case number or name, where your host name is the name of the computer being investigated, which would be Mac, Windows, whatever you wanted to use. For your lab, it would be your Nexus 5 or other Android phone. I did it on Nexus 5 off an old phone that I had for a few years ago. So in summation, Unix is created to be multi-user, multi-threaded, secure OS. The Linux kernel is packaged with other software components, such as a GUI and applications. Linux supports a wide variety of file systems. Unix and Linux have 4 components in common: the boot block, super block, inode block, and data block. The Linux file system is a hard link, is a pointer that allows accessing the same file by different file names. Before Mac OS X, it was HFS and HFSX, and Mac is considered file consists of 2 parts: the data fork and the resource fork. A volume is any storage medium used to store files. plist files are files for installed applications on a Mac system. The biggest challenge for acquiring images for Mac system is often the physical access required to get to the drive. Linux forensics tools are often freeware or open source. So that kills off and finishes out our Chapter 7 notes. If you have any questions about your assignment, please email me directly. The biggest part of this one is just what you thought of it, what you got out of it, because you've been using Access Data, you've been using WinX, you've been using a few other software kits by now. This is kind of a change and just opening up more doors here.